what's up, 5th grade? We are going to start lesson 2 in chapter 5, and lesson 2 talks all about the stars and constellations, and it's going to be a lot of fun. And did you know that the sun is actually a star? Bet you didn't know that. Actually, some of you probably knew that because you guys are really smart. But we are going to talk about the stars today because you guys are probably sick and tired of talking about rotations and revolutions and the orbit and the axis. You guys have heard me talk about that for like a week now, and I'm sure you guys are all sick of it, but we are going to talk about the stars now. So I need you to get your purple science book and turn to page 178. Get it out, 178 in your purple science book. That is chapter 5, lesson 2, page 178. Grab a highlighter, grab a pencil, and let's get started. Alrighty, everyone should have their books now. What is a star? We are going to discuss all about stars, all about what they are, all about all kinds of stuff, characteristics, why it's important. Alrighty, we are going to start out on page 178 talking about a misconception. Do we know what misconception means? It's something that we think is true, but is actually not true, and why we think it's true, okay? So, the misconception that we have, what happens to the stars during the day? You might think they disappear, but they do not. The stars are always in the sky during the day, just as they are at night. However, the sun's light is so much brighter than the faint light coming from the stars that the stars cannot be seen. On a dark, clear night, without the aid of a telescope, you might see over 1,000 stars in the sky. So, even though the stars are there during the day, you just can't see them. All right, I want you to answer the question on page 178. Do all stars look the same? Explain. What do you think? Do all stars look the same? Yes or no? And then tell me why. Why do you think they look the same, or why do you think they all look different? Pause the video and answer that. Okay. I'm going to guess that you unpause the video now and you're ready to learn more about stars. I love talking about the stars. We're going to talk about 2 important vocab words, a solar flare and a constellation. I'm sure you've heard constellation before. A couple of you may have heard about solar flare, but let's talk a little bit more about it. So, on page 179, let's start with stars. Stars are gigantic balls of very hot gas that give off radiation. Let's highlight that. It's Mrs. Glodeck. She's going to have to hold on. The sun is a medium-sized star. Stars, known as giants, may be 8 to 100 times as large as the sun. Supergiants are even larger. They may be up to 300 times as large as the sun. A star at the end of its life can collapse and become very small, only about the size of the Earth. Even though the sun is only a medium-sized star, it is the largest object in our solar system. I want you to highlight that. Oops. So even though the sun is a medium-sized star, it is the largest object in our solar system. Scientists have been able to calculate the mass of the sun's mass from the speed of the planets and the shape of their orbits around the sun. The sun's mass is nearly 2 million trillion kilograms. You can write that as a 2 followed by 30 zeros. That is a huge number. The sun has almost 100% of the mass in the solar system. The sun is huge when compared to Earth. In fact, the sun has more than 1 million times the volume of Earth. If you think of the sun as a gumball machine, it would take over 1 million Earth gumballs to fit the sun gumball machine? I want you to highlight that. If you think of the sun as a gumball machine, it would take over 1 million Earth gumballs to fit in the sun gumball machine. What that means is it would take over 1 million Earths to fit inside the sun. That is huge. All right, number 1. You're going to answer question number 1. It says, compare the size of the sun to the size of the other stars. Compare its size to the Earth. So it talked about the size of the stars up here. Okay, so number 1 talked about the size of the stars up here. We talked about medium-sized stars, stars known as giants, stars known as supergiants, and then the end of a star's life. So we have a medium-sized star, we have a giant, we have a supergiant, and then a star at the end of its life. Okay, so that's going to help you with that one, and then you can use down here to answer that one as well. Number 2 says, how can scientists determine the mass of the sun? We talked about that in here as well. So you pause the video, go ahead and answer those 2 questions. Oops, let me get this off the screen. There you go. Pause the video, answer those questions, and then unpause it when you're done. We're going to talk about characteristics of the sun. The sun is a fiery ball of hot gas and has no hard surface. It gives off enormous amounts of light and heat. The outer part of the sun is about 5,500 degrees Celsius. The inner part of the sun could be, the inner core could be as hot as 15 million degrees Celsius. So we're going to highlight the first sentence. It's a fiery ball of hot gas with no hard surfaces. I'm going to talk about the sun's atmosphere. So like Earth, the sun has an atmosphere. The innermost layer is called the photosphere. It gives off the light energy you see. The layer above the photosphere is the chromosphere. The outermost layer is called the corona. When scientists look at the sun with special equipment, they see dark spots called sunspots moving on the face of the sun. Sunspots are part of the photosphere. They may be the size of Earth or larger. They look dark because they are not as hot as the rest of the photosphere. The number of sunspots increase and decrease in cycles of about 11 years. I want you to highlight the innermost layer is called the photosphere. It gives off the layer that we see, the light we see. We're going to highlight that the layer above is called the chromosphere and the outermost layer. I'm going to highlight that dark spots called sunspots move on the sun. We're going to highlight that the number of sunspots increase and decrease in cycles about 11 years. Now we're going to talk about solar eruptions. That sounds fun, doesn't it? 2 types of eruptions take place on the sun. 2 types of eruptions that take place on the sun, sorry guys, are are premonitions and solar flares. A preeminence looks like a ribbon of glowing gases that leap from the chromosphere into the corona. They may appear and disappear in a few days or months. So let's highlight that. So it looks like a ribbon of glowing gas. And they appear and disappear a few days and months. And then we have a solar flare. A solar flare is an explosive eruption of waves and particles into space. Solar flares are similar to volcanoes here on Earth. A solar flare causes bright spot in the chromosphere that lasts for minutes or hours. Along with extra bright light, solar flares also give off forms of energy. This energy is powerful enough to interrupt radio and satellite communication on Earth. So let's highlight the definition for a solar flare. We're going to highlight that it causes a bright spot in the chromosphere that can last minutes to hours. So number 3 says, what are the physical characteristics of the sun? So what are some physical characteristics of the sun? And number 4, why might space agencies not want to send astronauts into space during a solar flare? And take a look at this page. You have the sun. Here's the core. Up here it says solar flares give off more light than other parts of the sun. They emit radio waves, visible light, X-rays, plasma, and other radiation. Number 5 asks, what is a solar flare similar to on Earth? And we answered that with reading over on the other page. Once you've answered those questions, turn the page and continue reading with us. Let's talk about constellations. In the past, people looked up at the night sky and connected the dots formed by the stars. They saw patterns that reminded them of bears, dogs, and even a sea monster. Today, scientists divide the night sky into 88 constellations. A constellation is a group of stars that form a pattern. Highlight that. It's kind of hard to see the highlight on the black, so really you're just looking at the letters that are colored in. Many constellation names are the names of star patterns that people used long ago. The star pattern called the Little Dipper contains a star called Polaris. Polaris, or the North Star, is a very hot and very large yellow-white star. It is almost 2,500 times brighter than the sun. It does not look larger than the sun because it is much farther away. Polaris is an important star in navigation. I want you to highlight that. Because it is almost directly above the North Pole, Polaris doesn't seem to move as the Earth rotates. Highlight that as well. If you can find Polaris in the sky, you can tell which direction is north. Early explorers used Polaris as a guide to direct them in their travels. If they located Polaris, then they could determine in which direction they were headed. If you look at number 6, it asks, why is Polaris called the North Star? And number 7, how might constellations help scientists study the sky? Let's pause the video, answer those, and then let's move on. Stars on the move. Stars are not always in the same place in the sky. They move in particular ways. Suppose you looked at the sky early one evening and found the Big Dipper. When you looked 2 hours later, the Big Dipper seemed to have moved towards west. Actually, the Big Dipper did not move, but you moved. The spinning of Earth makes the stars to appear to move from east to west across the sky. Highlight that. And what do we know that the spinning of Earth is actually called? Earth is really rotating. Good job, guys. I heard you all say it. Over here it says, stars appear to spin around Polaris in this time lapse of the photo. So here you have Polaris up here. That's that dot right there. And all the other stars are kind of spinning around it. So number 8 says, the time-lapse photo shows how stars seem to move as the Earth rotates. Why are the stars in a circular pattern? And then number 9, if stars are bigger and larger than the sun, why does the sun appear so large? And number 10, what is the significance of Polaris, the North Star? So why is it important? Why is it important? Why is it significant? If you have any questions, please let me know. Make sure you answer all the questions in the book. You just have 10. Take a picture of these if I don't see you in class and submit them to me. If you're having trouble taking the pictures and submitting them to me, since the questions are all numbered, you are more than welcome to type them up on a Google Doc and submit them to me that way. I'm fine with that if that's easier. If you have questions, comments, concerns, you want to tell me something cool, email me, let me know. Comment on this Google post. I hope you guys have a great day and enjoy learning about the stars.